Right, hello everybody. We are continuing our discussion, introducing probability, the probability concept, and transitioning to conditional probabilities. Now, I will say, first of all, if you have not watched the previous session, then this won't make as much sense as intended. So feel free to skip and go and watch that first. But if you have, then let's continue that discussion. We talked about exercise, what was his number? I should know this. 6.1, 6.1, where we looked at 100 people. They had properties male or female, as well as graduating from in-province or out-of-province high schools. And with a table, we're able to oh, let me just check before we continue. I've had some problems this morning with people not seeing the screen or hearing anything. Can I just get verification that you can see everything and hear everything? Okay, just to be sure.
I can see and hear you. You're all good.
Okay, perfect. Thank you. All right, let's continue. So that part is going through. So it's something with Discord. Maybe uh figure out. But YouTube does work, so that's good to know. Okay. Uh let's remember what we did here. Our table worked because of how the information was presented in terms of giving me all the numbers pretty much. And I was able to fill in all the little areas in my table. And then it's pretty much, they can ask me anything they want. I just pick from the numbers. If I need to find the probability that a person has in province or female, then I'll just pick the numbers appropriately, satisfying those restrictions, and put it over the 100. We can see this in a different way, which I don't necessarily think is better in this case, just different. When it comes to conditional probabilities, I don't necessarily want to look at a Venn diagram, but I'll show you that as an option. Not doing a full question, but let's just say here, different view of that same situation. Let's set up the Venn diagram, nice and big. And the circle, this is just, excuse me, this is just one way of setting up the Venn diagram. I could say, let F represent the event or set, it's the same thing, right? Um, that the person selected is female, and then this will be my F. I'll put it sort of on top of it. I don't need a circle for male as well, right? Because I guess this is sample space. Because the outside will then be the other option based on this question, male, female. So by having one circle for female, all the females are inside and all the males are outside. Then I do need another circle for the other property. Let's go, I guess, I for in person. We've already really defined this. I represents the event that the person is in province. So I'll call that I. I'll sort of put it on top of it. And again, I don't need one for out of province because the outside of the circle is the area that contains the out of province people. Now, I don't want to dwell on this too much. It's going to get me to where I need to go, and then I won't look at Venn diagrams for conditional probabilities again. It's ineffective, I think. So here we see that, like the table suggests, and I'm not putting numbers in, there are females that are out of province over here. There are females that are in province. There are males that are out of province, males that are in province. So I do cover everything. So now I want to look at that last question where it says, what's the probability that the student graduated from an in-province high school given the student is female? So I'm looking, let's move up a little bit, looking for the probability of being in province given female. Now I'm going to write this. I have a crazy cat right now. He has little bursts and then he runs around. I'm going to write this in more symbolic notation using the events I defined, the probability of what I'm looking for in province, and then I'm going to put a longish line separating what I want from what is given. And the second part is going to be what is given. And this is going to be called conditional, writing sideways here, probability. Because I have extra information. What does that mean here? So if I didn't have that, get that for a second, and I just asked what was let's not do it on top there. If I just had it over here, what is the probability that the student was in province? I would simply look at how many are in that circle, the I circle, and compare it to everything. My very ugly S. Up here is the sample space, the universal set, everything, right? But now that's not the case here. Now they tell me extra information that I can use, I can exploit. It's a fact. It's not up for debate. The person selected was female. Now all that matters is the female circle. Let's make it blue maybe. Some sort of purple. All that matters is the female circle. And I sort of refine my view, reduce my options to this circle because I have extra information. I know for a fact the person that was selected was female. So now what I'm calculating here is really out of the females, how many were in province. Yeah, I should do that blue. Which help a lot. Out of the females, how many were in province. Because I have this extra information, I don't care about the outside. It's impossible. How many of these in the blue circle satisfy the in-province requirement? Only these guys. Or girls, I guess. Only these. So that would be the, well, any way, in any order you want, the intersection of in-province and female. It's a reduced sample space. Because of this given information, it's fact, I can use it, and it changes the probability. It changes the chances of getting an in-province person because I'm restricting myself to just females because I know it's a female. So this extra information changes the probability, changes things. As soon as I know a little more about what has happened, sort of behind the scenes, someone gives me some inside information, the person that's selected, so there's a selector of this random person. And before I calculate a probability, they whisper to me, hey, it's a female. Oh, well, that changes things now because the proportion of in-province females to females isn't the same as in province people to all people. It's not the same. Say, not necessarily the same. It could be in some rare cases, sure, but most of the time it won't be the same. Okay, so let's not look at that Venn diagram for too long. So now here, this is great if I have a lot of information and I have numbers. I can count these quantities, right? These regions. But that's not always going to be the case. So here, uh, let's just note, I would like to have sort of a formula to figure out how to determine this conditional probability. The I and the F are irrelevant, right? It's some conditional probability based on the, I'll call them normal probabilities, where nothing is given. Well, if I have this, I can take the pink number at the top, it's just a number, and divide that by the sample space. And I can do the same for the bottom number. And because I have done the same thing at the top and the bottom, nothing has changed. But now the top, just in isolation, is a normal probability of the intersection of these two, right? It's relative to the sample space. So it's relative to the whole rectangle, to everyone. And the bottom one is the probability of F, just relative to everyone. It's a normal probability or conventional probability. So now don't really care about this. I do it once to explain why I get this. This is now going to be my formula for how to make sense, not make sense, how to determine and calculate a conditional probability. I can rewrite it to two conventional probabilities. Let's do it in general. In general, give me two events. Any events, E and F. The probability of E given F, I just used F again, it doesn't matter what they're called, right, is the conventional probability of the intersection divided by the probability of the given one only, as if it's not given. So I have to sort of put blinders on here and identify. Am I trying to find a conditional probability? Yes. Then calculate two separate things as if they're brand new questions and put them in here like this, and that will be your answer. Let's go to our exercise 6.1. What's 6.1? 6.1. And just look, if we get the same answer as number 6, do we get 0.75? Without looking. Right? So there, our question is the same. This is number 6. Back to probability of in province given female. Using this now, and only this is what I'm going to use forever. It says find the probability of the intersection and divide that by the probability of the given event. Okay, one at a time, completely separate from each other. Probability of in province and female. In province and female. It's this guy, right? It's conventional probability 30 over 100. Probability of female is 40 out of 100. 40 out of 100. I can then simplify this and I'll get 0.75 again. Same as here, same as this one, but this one I had the luxury of having all the numbers in my table, and that's not always going to happen. So the table is nice if they give me all the numbers. It's sort of like the basic situation, but information can be presented in a way where I don't have numbers. I might just have probabilities and percentages. Then the table, in my opinion, isn't necessarily as intuitive or as easy. Sometimes, technically, I can't do it at all. Regardless, whenever I have a straightforward probability, a conventional probability in combination with something else, or just on its own, I calculate it in the normal way relative to the whole sample space. When I have a conditional probability, I have to rewrite it in terms of two conventional probabilities and then calculate those two separately and then calculate in the end. Okay. All right. So this is pretty good news. Yeah, I understand conditional probability is a little messed up and it changes things. And I don't know how it changes things. It's not intuitive for me. I rewrite it and then I just calculate two straightforward probabilities and put them together in this way. And that can sort of sidestep the confusion that my intuition has with conditional probabilities. Okay. So I need to memorize this. I need to memorize it. Probability of the intersection of both over the probability of the given one. Always. It's never going to change. That's it. All right, so far so good, I hope. Let's keep going with this situation and view it in another way that can help me when the numbers aren't presented this nicely. Another way of visualizing the information, but not on that page. Page here. And it's all a matter of how the information is presented. I then decide, okay, what's my best plan of attack here? What makes it look the most clear for me? I'll then go with that. Okay. So what did we say up here? A different view again, but this one's going to be very handy for certain kinds of problems where they give me percentages and proportions from the start and I don't ever have numbers. This view is going to be better, but it'll also work. Whoops, it'll also work when I do have numbers. So it's kind of the catch-all method. That is definitely my preference. So I want to think of it sort of as an action, as an experiment. I'm starting here. This is my start. I am now the selector. I am going to randomly choose a person from the 100. And I'm going to take note of their properties, but one at a time. I don't need to write down all their properties. Maybe I can only answer them one specific question at a time. I pick a person. That person has two options for my first question. That's not right. And my first question is going to be, are you male or female? Now I'm just going to write this in words for now. We will update this in a second according to our predefined, already defined events, I and F, like before. That almost looks like a P. So for now, let's just do it in words to see what this tree is trying to say. So I asked them, are you male or female? They're going to pick one of these two. And there are probabilities associated with how likely they are to pick either one or to answer. It's a random person, right? What is the probability? Go to my right page here. What is the probability of the person answering male? Well, that's going to happen if I pick one of the 60 out of 100, because there are 60 out of 100 males. So the probability here will be 60 out of 100, and I'll put it right on that line. The probability of selecting a female will then, of course, be 40 out of 100. So right now, with this diagram, I'm just trying to map out what could happen if I randomly select a person. I could go off on this branch, having selected a male, excuse me, or I could go down this branch, having selected a female, right? It's random. So either one of those two things could happen, but if I focus on male, female, only these two things can happen. Nothing else can happen. However, regardless of if I took the male route or the female route, there's another property that the person can answer in two ways, and that's the in province or out of province question or property. So I have another split. If my selected person is a male, I ask them their next question, are you in province or are you out of province? Or I guess, were you? They can answer that with different probabilities. But when I'm asking them this question, they are already male. I've taken this step. I've sort of seen part of their properties. Now I ask them the next question. So out of the males, there are 60 males, 40 are in province, 20 are out of province. So the chance of them answering in province, what did I just say? 40 out of 60. And out of province, 20 out of 60. Because I've taken the male step and now I'm asking them their next question. So it's all technically conditional probabilities. This is the probability, I'll write it informally, of being in province given it's a male. Because when it's a female, I'm going to take the bottom branch and then ask the same question. Either way, I'm asking the same questions, but different things could happen in the sequence of questions I ask. If my selected person is a female, I will still ask if they're in province or out of province. And they can answer with different probabilities, but it's restricted to the females. From the females, there are 40. 30 is going to answer in province, 10 are going to answer out of province. So the probability of being in province given your female is 30 out of 40, out of province, 10 out of 40. So now look at this probability, for example. I'll write it because we're familiar with the I and F um, events that are defined already. This is the probability of being in province given female. And notice that is the 0.75 we've been calculating. Now there's a luxury here that we have the table and we have the numbers already. Very different ways of calculating the same things depending on how the information is presented. We'll see eventually. But I don't want to go too fast right now. So the first split is a conventional probability. Not this one. Let's do the other one here. Wow, eraser mode. Bottom one here. This is just the probability of being female. Conventional probability out of the whole sample space. Once I take that step, now I'm deeper in. Things have happened and I'm asking more things. So I'm sort of in the middle. Some things are given, having taken some steps in my diagram, and now I'm asking more things on top of that. So now these are conditional probabilities. All right. So this tree diagram maps out all the different things that could happen. For example, if I follow this blue path, that is going to be my sequence when I've selected an out-of-province male person, student. I would have taken the top branch for my first question, then the bottom of the next two for my second question. So every combination is covered here. Male in province, male out of province, female in province, female out of province. Now I can answer any question using this diagram as well, instead of the table. Let's run through the questions. So not using the table itself. Now, how I'm using this isn't the same as the table, in my view. I have to go from the start. Why am I blue? No, no, no. No blue. Go away, blue. I have to go from the start to, I guess the finish is over here after my two questions. From start to finish. The first question is, let me just backtrack. I don't want to do it. I want to do it in the right order. Let me just write new examples, maybe on a new page. Some questions I'm using a different approach. Some questions might have been easy in the table method, and it might be less than obvious if I start with those. So let's just do this in a order of difficulty that works with my diagram. Of course, I can't technically answer everything, but I want to build up from easy to hard. Easiest would be, for example, probability of being female. Straightforward probability, and it's the first branch. It's just 40 out of 100. Okay. It's easy because that one is visible on the tree diagram already. It's right there. I read it off. It's the first split. Okay. Now, technically, I should. This is correct, but technically, I always, ideally, let's say here, ideally should always go start to finish. So I need to ask a slightly different question here. I need to ask, out of the paths here, top one, I have this one, I have the bottom first one, and I have 4 paths. Which ones produce a female result? It's the bottom 2, right? It's this one and this one. Because I don't care about in province or out of province as long as I take the female path. Female with in province, female with out of province is okay. So technically, I'll say it like this: the probability of female, I'll do it informally, is equal to the probability of path 3 plus the probability of path 4. If I stop halfway, in some cases, it's going to be risky. I should go start to finish. And if I let the person, maybe not me, ask their 2 questions, male, female, in province, out of province, the results could be this one, path 3, let's say, or the results could be that one, path 4. In either of those cases, the probability will be a female, or not, the outcome that I'm interested in will be female. I don't care about province or out of province. So the question that will sometimes be more important than perhaps this one is, what do I do with a path? What do I do to find the probability of this path? Well, if I look at path 3, diagram here, it's the probability of being female and then in province. So that's the intersection. Probability of female and in province. And path 4, let's just pause and finish past path 3. How do I find this probability? Well, if I sort of go on the side here and remember the definition of a conditional probability we've seen a couple of times now, I call it the definition, call it the formula, do whatever you want. So it's the intersection of the two over the probability of the given one. Now I can swap these around, right? These are interchangeable inside an intersection. If I now multiply both sides by this bottom, the denominator, I get the probability of this conditional probability that was on the left, and then I multiply both sides by this P of F, and then I just have the intersection on its own. So now let me just clean this up a little bit to match what I have here. I and F, F and I, doesn't matter. And I'm going to write the single one first and then the conditional probability. This is an alternative to the original formula. See, is that on the screen here? Yes, okay, good. This is an alternative to the original formula. But this probability, this intersection, is exactly what I'm looking for. This says, and it's going to be much clearer once I go to the tree, just give me a second. Writing this alternative version of the formula for conditional probability, it says I can find this intersection, which is the probability of path 3, by multiplying these two. But these two are the ones on the tree. The probability of F, right there. The probability of being in province given F, it's right there. Because the way I set up the tree, the later branches already contained conditional probabilities. So doing this alternative form of the formula, let me just see, what was this? 40 over 100, 40 over, and this other guy was 30 over 40. Now it simplifies in this case because it's a simple question to begin with. And I multiply them. So to find the probability of a path, I multiply along the path if I've set up the tree correctly in this way. If the probabilities later on in the tree are conditional probabilities, then to find the probability of a full path from start to finish, I multiply these probabilities. I multiply along the path. That can work if the tree is much, much bigger as well. And the same thing for this. I don't need to write this ever again, really. I'm just doing it the first time to understand why do I multiply along the path. It comes from the formula for conditional probabilities and how I set up the tree. But once I've done this, I'm not thinking of this ever again, honestly. I now have my tree. I read it off my tree. I just need to know how do I read it off my tree. So for example, the probability of path 4 is now this one, right? Sure, my diagram doesn't get too messy. Multiply along the path. 40 over 100, 10 over 40. 40 over 100 times 10 over 40. Now this one is pretty simple, so it'll cancel and simplify and stuff. But when I get more difficult probabilities that aren't immediately visible on the tree like this one was, I might have to look at full paths. So let's just clean this up a little bit and see what are all the variations in questions and how do I use the tree. Is something different? Is there anything that I can't do? Answer is no, I can do everything. I just need to understand what my tree is giving me, how it is presenting information. Some of its probabilities are conventional probabilities. Some of its probabilities are already conditional probabilities. So I just have to be aware of that. So simplest case, I made it much bigger here to get to this probability of a path, which I could have done later in hindsight. Easiest case is if they're asking for a probability that is already on the tree, like this one. Oops, press remote, done. If they're asking me the probability of selecting a female, I already have it. I can just extract that. Alternatively, if they ask me, what is the probability of out of province given it's a male. Out of province given male. It's already there. The way I've set up my tree, I needed those probabilities and I filled them in. So reading it from the tree is just picking this guy because this guy is exactly. Having taken the male step, given male, what is the probability of being out of province? 20 out of 60. 20 out of 60. So a couple of kinds of probabilities will be immediately visible on the tree, and I can just copy them. Now, it depends on how I've set up my tree. I set up my tree first. Then I look at their questions. They can only ask so many, right? There are only so many events here. Sometimes what they are asking for, whether it's a conventional probability or a conditional probability, it's already on the tree. I've actually already done the work, and now I can just reap the benefits and write it down. So definitely always check. And we'll write down the steps maybe afterwards. Check. Is the probability they're asking for already one of these that are on the tree? Then write it down and move on. Your tree will be defending your answer. Your tree will be your work shown. But sometimes it's not going to be right. The next one in terms of difficulty could be the probability of, let's say, in province. And that's it. So now I have to ask myself, what kind of probability is this? It's a conventional probability, right? There's nothing given. I can write this as the probability of I. So you don't have to if you don't want to. I look, is that probability somewhere on here already? No, because in province can be obtained, the requirement in province can be obtained by taking the male branch, but also the female branch. There are multiple ways to end up with a person that is an in province student. So now I have to go start to, now I don't have a choice. I have to go start to finish, take the male path, and get to in province. Yes, I could take this top one. So I'll call them path 1, 2, 3, and 4, just so my sketch doesn't. So it's the probability of path 1, which will have an answer. But also, so I have to add them together. I can also get it, I can also get an in province person with path 3. Probability of path 3. So now I look at those paths separately. How do I get path 1? I remember, to get a full path start to finish, I multiply along the path. So 60 over 100 times 40 over 60. Plus, probability of path 3 is another way I can do it. And they are not overlapping. I then add them together. For path 3, multiply along the path. That's the probability of the path. So 40 over 100 times 30 over 40. Now, it's sort of just simplicity of the question that these cancel. It's not always going to happen. And there you go. That's my answer. I don't have to go all symbolic and do stuff here, but if you want to, I totally can. It doesn't really help. Path 1 is the probability of being male, which is technically not female, and the not probability. What was path 1? In province. Sorry, no, female. Sorry, I mixed them up. Not female and in province. Path 3 is female and in province. Female and in province. And then these guys will be split up. Probability of male, so not female, times the probability of in province given, not female. Probability of female times probability of in province given female. But why do I need this? Why? I don't need it. I just need the answer. Do it in words. As long as you understand which to look for which paths from start to finish can give me this property. Top path, third path. Then I'm going to add up their probabilities to find the probability of a path, start to finish, multiply along the path. And you can then calculate that, plug it into your calculator, do whatever you want to do. 70%. Doesn't matter, right? The answer is a formality. It matters, but finding it shouldn't be difficult. I don't need to write everything in symbols and get distracted by this. I just need to know how to use the tree. So we have situations where the probability they ask is right on the tree already. Whew, job done. Copy it. Move on. But sometimes the requirement, the event that they're asking for, isn't just something that's on the tree already. Then I have to find the paths that do satisfy that event, that requirement, start to finish, add them up, and each one multiply along the path. Now I set up my tree like this. I decided to ask male, female, then in province, out of province. There's another kind of question that feels a little backwards, and that's arguably the most difficult one. But we'll see, I can use my tree in a very similar way. Probability of in province. Let me just think. No, other way around. Let's say probability of female given in province. Now, this is a little opposite to how I set up my tree. In my conceptual scenario, the interviewer selected a person, then asked first, are you male or female? Then the province was their follow-up question. So I set up my tree like that. I had to make a decision. It doesn't actually matter which question was asked first. In another conceptual scenario, the interviewer could ask first, are you in province, out of province? And before their next question, they whisper to me, the person was in province. What do you think is the chances that they're female? Well, I don't know because my tree isn't the same as the order that you asked your questions. Either way, I know you're going to ask two questions and the end results will be the same, but the path that I take isn't the same as the path you take. So that's a little bit of a weird question. Given looking at my tree, you're asking things backwards here. You're asking what are the chances of being female given something that I have coming later, only because I had to make a decision. And practically speaking, I don't know which order the questions are going to be asked. Could be the other way around. It's not a big deal. What I have to understand is it's a conditional probability. It's a conditional probability. Let's write it down. This is the probability of female given in province. Right? I'm going to stick to events we've already seen. This one is tricky because people might think too fast and expect this to be on the tree, but it's not. See, this one's different. It's not the same thing. This one was given female probability of in province. It's not the same as what we're doing now. It's swapped around. This one is given the person's in province was the probability of female. And intuitively, that messes me up because I don't know what to do. It's flipped around. I have no idea. First thing is to understand we're looking for a conditional probability and that it is not on the tree directly. It is not these guys. It is the other way around. It is not this. It is something else. I don't know what it is. But that is the first step. Do not be fooled and think, oh, well, it should be on the tree, right? It sounds like it is. No, it's not. You have to pay very close attention to the order in which these events appear, which one is being asked, which one is given. Okay, so now that I've established that, I really have only one choice. There is a formula to rewrite this confusing conditional probability to conventional probabilities that maybe I have a better chance of finding. It is always the probability of the intersection over the probability of the given event. Always. Won't change, ever. But now at least I have a chance. Because now I can say, actually I'm going to do it at the bottom. I can write some descriptions up there. Now I'm going to say, ooh, this guy, female and in province. This is path. Female and in province. I have to backtrack on that so I don't get a messy diagram here. This is the probability of path 3, I'll call it, right? Path 3. Start to finish. Conventional probability, start to finish. I do them separately. So let's just do that one above the line. Probability of path 3, now I understand, I've seen it before, how to find the probability of a full path, multiply along the path. So 40 over 100 times 30 over 40. It's nicely simplified in this case, it won't be always. Done. Good. But that's only part of it. The bottom still needs to be addressed. That one is not as strict. The probability of being in province. Which paths can give me that? This path or this path. So both paths 1 and 3 will result in a person being in province. So it'll be the probability of path 1 plus the probability of path 3. Because I can get it in two separate different ways. Now I just go, okay, what is the probability of path 1? Multiply along the path. So 60 over 100 times, what was it? 40 over 60. Plus probability of path 3, 40 over 100 times 30 over 40. Don't worry too much that I have it at the top as well. It's not coincidence, but it's safer, I think, if you just treat these completely separate from each other. Now you plug that into your calculator and you get what you get. I guess we could do it. Sure. Have the time? Why not? This simplifies nicely, actually. It won't always, so it's 30 over 100. And those simplify nicely, 40 over 100. Much work to put into my calculator. Simplifying it would be nicer. So that's 70 over 100, so it's 3 over 7. Maybe let's show something. Sure, it's nice to show something, I guess. 0.43, if you want to round aggressively. I prefer 4 decimals. 4286. Squeeze it in here. Can I see this? Is it not in front of a webcam? It's good. Or let's just do it over here. 42.86%. That's nowhere on the tree. And it's simply it's simply because I didn't set up my tree in line with what that question would have done, practically speaking. In this question, the scenario I imagine is that the person asks the province question first, then whispers to me, Oh, the person's in province. It's a fact. What do you think are the chances of them being female? If I lucked out and at the beginning did the province question first in my first split and then male female in my second split, mapping out the scenarios would have been the same. It's just in a different order conceptually. That question then would have been super easy. However, pros and cons. This question would have been easy, but this one would not have been. So either way, there's a hard and an easy version. I might as well just stick to a layout of a tree diagram that I find the easiest to understand, and then work with that. And whatever they're asking me, sometimes it's hard, sometimes it's easy. It doesn't really matter, right? I just have to know. I'm not going to change my tree diagram to ask their question, to answer their question if it's a difficult one. That's actually more work to redo your tree diagram. That's more work. You might as well just do the formula, and it didn't take that long. But this is the worst case. And intuitively, it feels a little weird that in my tree diagram, I imagined asking male, female first and then province. How would I know the answer to the second question and not the first? Well, because I didn't know what was actually happening. It was just a conceptual breakdown of the experiment. I don't know exactly what happened. Could have been at the same time. Who knows? So conditional probabilities can get a little confusing, but it's better to remember that this tree is just mapping out from start to finish different results. In the middle, I choose a sequence that I want. I don't know what's actually happening in some cases. All right, that was a lot, perhaps too much. But that gives us everything. We're going to start tomorrow continuing this discussion because we obviously need more examples, right? There is another exercise in the book. I'm going to give the steps for different, how do I handle the different probability questions? There are only 4 things I could possibly get. How do I approach, sort of a flow chart? How do I approach handling the different questions? Then we're going to look at an exercise. We're going to look at some more problems, and hopefully that will give you the big picture of how to navigate this much more confusing situation, but practically much more relevant as well, which we'll see tomorrow with some examples. All right, are there any questions at this stage? Don't worry about any problems. Don't look at any problems yet. Need some more examples just to run through this again so that you can have a big picture and see where the issues may come up before you put a variety of other problems on top of that. Any thoughts or questions at this time? I know we're a little bit behind in our playlist about the
Is
video on the videos,
is
and I'll upload them soon. Yes.
is there any exercises you'd recommend?
No, I just said don't look at any problems or anything.
Okay.
We're not, I don't, I mean, you're welcome to,
No,
but
no.
I think it's better if we wait until tomorrow. We're not in a hurry. It feels a little strange, perhaps, like, oh, I need to be practicing stuff. No, this just is a lot longer discussion that unfortunately needs a couple of sessions before I personally feel we're ready to look at problems on our own. These aren't going to be as simple. So I want to be sure I can handle whatever the question is, look at it the right way, whatever the probability question is. I want to set up my tree, understand what they're asking, and then react according to what that probability is. So we just need a little more practice and example and one more discussion, and then you can go on the weekend and do all the problems you want. So for now, just review the video, try and get on top of what we said, try and isolate which part you're not happy with so that when it comes up tomorrow, we can make sure. patience. Any other thoughts or questions? All right, then we will just pick this up and continue tomorrow. Until then.